We go over rotation motion practice questions. The first question given here. A race car accelerates uniformly from a speed of 40 meters per second to a speed of 60 meters per second in 5 seconds while traveling counterclockwise around a circular track of radius 400 meters. First question given. When the car speeds reaches a speed of 50 meters per second, what would be the magnitude of the car's acceleration? Well, this car is moving in a circular path like that, and from the center the distance is 400 meters, that is the radius. Now at an instant where this car is moving at a speed of 50 meters per second, what is going to be the magnitude centripetal acceleration? The centripetal acceleration is the acceleration that moves towards the center. The acceleration is pulling something towards the center, something that is moving in a straight line. So how can we find centripetal acceleration? So centripetal acceleration, is actually equal to velocity squared divided by r. The centripetal acceleration is sometimes called the radial acceleration. So the velocity at this instant is 50 squared divided by the radius, which is 400, and that is going to give us 6.25 meters per second. And then part B, the angular speed. Well, to get anything linear, you just multiply the radius by what is the angular. Linear velocity is radius times angular velocity. Linear acceleration, radius times angular acceleration. Linear distance is radius times angular distance. And so in this case, the velocity linear has been given is 50 at this instant, and then the radius is 400. Now what will be the angular velocity? Divide both sides by 400. So the angular velocity is going to be 50 divided by 400, and that is going to give us 0.125. Because it is angular, it is given in radians per second, because the distance in angular terms is not in meters but in radians. We measure distance in terms of angle, or displacement in terms of angle. And then part C, we want to calculate the tangential acceleration. Well, tangential acceleration, which is also referred to as linear acceleration, is simply final velocity minus initial velocity divided by the time. Final velocity, as we can see here, 60, it was moving from 40 and it covered this distance. It changed this speed in 5 seconds. 60 minus 40 is a 20. 20 over 5 is a 4 meters per second squared. Now lastly, we want to determine the magnitude of the total acceleration. Well, if you've got something in a circle, there are these forces which are acting, or the accelerations. There's always the acceleration towards the center, that is centripetal acceleration. I wrote 80, this is AC, centripetal acceleration. And then there's always a force such that if this thing which is moving slips off the path, it is going to go straight, and that is called the tangential acceleration. So these always make 90. The reason why I even call it tangent is because it makes a tangent to the circle. So if we get these two paths like that, where you've got centripetal acceleration, tangential acceleration, if we draw lines which are parallel to this, like that, and then we join it like that, this resultant acceleration is what is called total acceleration. So if this is 80, that means even this one here is going to be 80. The AC is this one which is here, which we can see. So we see what we are forming is actually a right angled triangle. So I can just remove this one portion and remove with only one part. And remain with just one part, which we can now work with. Now we can see that for us to find the hypotenuse here, because it's making 90 degrees here, for us to find the hypotenuse, just get 80, this one, square it and get AC. Also square it and square root. So the total acceleration is actually just using the Pythagoras theorem. So tangential acceleration is 4 squared, and then radial acceleration or centripetal acceleration is 6.25 squared, and then we square root that. So we are going to find the value that is 7.42. It is going to be in meters per second squared. Alright. Second question here. A ball swings through a circle of radius 90 centimeters and makes a 15 centimeters arc. Find the angle with which it swings. So when you have got something moving in a circle like that, we have got radius there. We know that the distance from this point back to this point like that is called the circumference. For a circle, the distance around the circle is called circumference, and that is given by 2 pi r. And so if we are talking about an arc, we are only getting a portion of a circle just from here up to here. Now how do we find that distance? So the arc is actually given by, you just get, because it is making an angle theta, so just get the portion. This theta out of the whole total of the angle, that is a complete revolution, 2 pi, and then multiply by the circumference of a circle. So we see this can cancel out. So actually arc length is given by r times the theta, or theta times r. So the arc length we've been given as 15 centimeters. The radius we've been given as 90 centimeters. We want theta, so divide just 15 by 90, and that is going to give us an approximate value of, alright, 0.17 radians. Now let's go to this question. A wheel accelerates uniformly from rest to a speed of 25 radians per second in 10 seconds. Find the angular acceleration of the wheel. Now we need to get to know this. When you've got something that is moving in a circle, there is always a force pulling it towards the center, and so it accelerates towards the center, and that acceleration is called centripetal acceleration or radial acceleration. When this thing moving in a circle move from the point, let me say point A to point B, it is the speed with which it moves in a circle is called angular the acceleration at which it moves in a circle is called angular acceleration. So at the same time, it is able to slip. Instead of just moving like that, it continues to go like that instead of turning. So the acceleration at which to move like that is called tangential acceleration, because it makes a tangent. So there are three basically acceleration. Tangential acceleration is also called linear acceleration just, and then centripetal can also be called radial acceleration. So part A, we want to find the angular acceleration. So this is the angular acceleration, and angular acceleration is given as change in angular velocity divided by change in time. Just as we know, acceleration is change in distance over change in time. So because it is angular, so we need to use angular terms. Because it was accelerating from rest, the final is 25 radians per second. The initial is 0 because it's coming from rest. Did this in 10 seconds. So we are going to find 2.5 radians per second squared. Alright, part B. We want to calculate the tangential and radial acceleration. Well, starting with the tangential. Tangential is also just referred to as linear acceleration. Anything linear is just multiplying radius by the angular term. So the radius in this case is 10 centimeters from the center. So convert 10 centimeters to meters. So 1 meter as 10 centimeters. As 100 centimeters. What of 10 centimeters? How many meters are there going to be? So x is going to be 10 divided by 100. That is going to give 0.1 meters. So the radius is 0.1, and then the angular acceleration is 2.5. So 0.1 multiplied by 2.5, that will give us 0.25. It is linear, so it is in meters per second squared. Okay, meters per second squared. Now after finding, we also want to find the radial acceleration, which is also called centripetal acceleration. So we'll say radial acceleration is given by, well, radial acceleration is given by linear speed divided by the radius. Now we don't have linear speed because the speed we have has been given as in angular form. So where there is linear speed, we know that anything linear is just radius times the angular counterpart, so squared, and then divided by the radius. So that is going to give us radius squared, angular speed squared divided by radius. So the formula just becomes r omega squared. So the radius we know is 0.1. Now acceleration is given as change in velocity over time. So even this value we are seeing here is actually change in velocity. Okay, and so it is final minus initial. So this value you can see here, how omega squared or angular velocity squared, we are getting the change in velocity. So the final was 25 squared. The initial, it was coming from rest, it was 0 squared, and then 25 squared multiplied by 0.1 will get 62.5. So this is going to be in meters per second squared because we are dividing linear speed, so that is why it is in meters. Alright, now let's go to question C. Question C is asking us how many revolutions has the wheel during this time. Now revolution, if we consider a circle, when a circle moves from 0 degrees, it rotates up to 360 degrees. In other words, it makes one revolution for every 360 degrees. And you know that 360 degrees is the same as 2 pi radians. So for every 2 pi radians, it makes 1 degree. So what we want to find is the angle. For what angle? What is the angle? In other words, what's the distance that this circle has traveled? This wheel has traveled during this time. We've been given we know the initial speed is 0. We know the final speed is 25. We know the time is 10 seconds. But how do you find the distance? And distance in angular terms is given as theta. So we look for an equation of motion that contains all these terms. So what we can use is theta is actually given by half omega initial omega final and then times time. So what we are doing is, just because we know that speed is distance over time, and so distance is equal to speed times time. Now this speed we are using is average speed, and average is given as final plus initial divided by time, and then divided by 2 and then multiplied by time. But because we are talking about angular terms, that's why we are saying I've used these symbols, because it is angular. Because this would have been linear distance if we are finding it, but this is angular distance or angular displacement. So that is going to give us half. It was coming from rest, so it was 0, and then the final speed was 25, and then the time was 10. So 2 can go into 10 5 times. 0 plus 25 inside here is 25, so 25 times 5 That is going to give us 125. This is going to be in radians. Okay, so this is the distance that was covered, theta. Now we know that if we make one revolution, then the angle involved is 2 pi radians. Now here the angle involved is 125 radians. How many revolutions will that be? So x is going to be equal to 125 divided by 2 pi. Just multiply this by that, and then multiply this by that, so it will be x 2 pi. So divide by 2 pi to remain with x. So 125 divided by 2 pi, that is going to give us approximately 20 revolutions, because 125 divided by 2 pi itself will give us 19.89. so I want to give it to a whole number, so that's why we just said 20 revolutions. Well, the last part of this question, so we've been asked find the angular deceleration. So this was supposed to be deceleration. Of the wheel if it comes to rest after 5 revolutions. So this is the distance it has to cover for it to go to rest. But what is this distance in terms of radians? We know that 1 revolution is equal to 2 pi radians. What of 5 revolutions? How many radians are there? So I can just say theta. So theta times 1, that would be theta. 5 times 2 pi, that would be 10 pi radians. So this is the distance. So it will come to rest after this. So if it comes to rest, that means the final angular speed is going to be 0. Well, what is the initial angular speed? So because it was moving at 25, so if it starts to go to rest, that 25 acts as the initial, because it will start from 25 and start decreasing. Now the question is how many revolutions. Find the angular deceleration. We want to find angular deceleration. Now how can we do this? So let's see what we have. We have got the distance, angular displacement, final and initial velocities. Now what equation of motion can we use? Because we know that acceleration is given by omega final minus omega initial divided by time, but we don't have the time, so we can't use this equation. But one equation of motion, we know that 2as is equal to v squared minus u squared. In angular terms, this becomes 2 acceleration is angular, and then theta is equal to omega final squared minus omega initial squared. So this is 2. The angular acceleration is what we want to find, and then the distance here is what we've just determined there to come to rest in 10 pi radians. The final speed is going to be 0 because it's going to rest. The initial was 25 radians, so 25 squared. So this is going to give us 2 times 10 pi, that will be 10 pi, and then alpha, that will be negative 25 squared, that is 625. So divide both sides by 10 pi. So that is going to give us a value of negative 19.89. So this is angular acceleration. It's negative because it's going to rest, so it is in radians per seconds squared. Alright, so that becomes the value in this case. Been given another question here. A ball of mass m, which is 0.1 kg, rotates in a circular path of radius 0.2 meters with an angular speed of 8 radians per second, while being attached to two strings equal in length. So these have got equal length. If this is L, this is also L. So they are both making an angle of 30 degrees with a vertical rod. Now I want to find the magnitude of the tension in the two strings. So what is the tension in this string? So tension is always a force that goes like that, which is holding this ball. Even in this direction, the tension goes like that. So let me say here we've got T1, and then here let me call it T2. Now first we need to write a free body diagram for this ball. So this ball is here. Due to the tension in this rope, there is a force acting upwards. Okay, on that ball there is that force acting upwards, and then due to the tension in this rope, there's also a force acting downward. Now if we can get just this ball here with T1, so what we are seeing is this T1 is there, and then this is making an angle here of, let me call it theta. Instead of saying 30, let me call it theta. Now we are saying there's something which is going like this. This is a for up, because this tension, because it is at an angle, to be broken into x and y components. So the x component will be going in this way, and then the y component will be going like that. Well, if we can see, the y component is going up, and the y component is the same as just this. Okay, because they are parallel lines. And to consider now what we have here, if we have got this thing like that, where we've got the angle here, we can just make a triangle like that. And then how do you find y? So with this angle, and then we've got the hypotenuse here, that is the adjacent to the angle, and so we're going to use cos, and so we're going to say cos theta is equal to, cos is given by adjacent over hypotenuse. The adjacent is y, the hypotenuse is T1. That means y is equal to T1 cos theta. So this is going to be T1 cos theta for ball 1. That means the x component for T1, the x component is going to, we are going to use sin. So there is an x component which will go like this. That is because the tension is going up like that. So that becomes T1 sin theta. Okay. Now if we go to the second tension, on the second tension what we have is, this is a ball here, and then we are making an angle theta at this point. Okay, so if we break it, we can just do that and make it like that, where, because we are talking about the ball which is here, the tension is going in this direction. So breaking in two components, we are going to have x component there, and then we are going to have the y component which is going down there. So we can say that the angle is here, x is opposite to the angle. So what we can just do, because x is opposite to the angle, we'll just say, when something is opposite, we use sine. Of course we can say sine theta is equal to opposite, which is x, over hypotenuse. The hypotenuse is this, which is the tension 2. So that means x is going to be T2 sin theta. So say T2 sin theta. But we also have, sorry, this is x, so I've written it on y. So we're saying there's an x component which is going in this direction, and that will be given by T2 sin theta. But for y is here, it is making an adjacent to this angle, so we are going to use cos. That becomes T2 cos theta. Okay, so there. Now by by reason of this being a ball, it has got weight. It has got a weight force going down. So that means we also have another force which is acting down here, and that is the weight force, and that is given by mass times gravity. After writing a free body diagram like that, now we can work in components. Let's start in the x component. Let's start in the y component. The upward forces, that means Ty, T1 cos theta, should be equal to the downward forces, that is T2 cos theta and what? Mg. Now T1 we don't know, cos we know the angle is 30 degrees for T1, and that is equal to T2. We also don't know the angle for T2 is also 30, and then plus the mass is 0.1, and then mg, that is gravity, is 9.8. So cos 30 is 0.866 multiplied by T1, so this is 0.866 T1, and that is going to be equal to, even here cos 30 is still 0.866, but this is T2, 0.1 multiplied by 9.8, that is going to give us 0.98. Well, at this point I can divide everything by 0.866. So we remain with T1 being equal to T2 plus 0.98 divided by 0.866. That will give us about 1.1316. Okay, there. So this is the equation that you found when you are dealing with the y components. Now let's go to the x components. When we are talking about the x components, we have got only motion to this direction. We don't have anything in this direction. And if we can notice, this ball is moving in a circle, so there is always a force that is pulling it towards the center of the circle. And so T1 sin theta and T2 sin theta are responsible for the force that is pulling this ball towards the center of this circle. And well, that means centripetal force, the force that pulls things towards the center, is actually going to be equal to the sum of these two, because they are the ones which are pulling this thing towards the center. So it will be equal to T1 sin theta plus T2 sin theta. We know how to find centripetal acceleration, that is given by v squared over r. From Newton's second law of motion, we know that force is given by mass times acceleration. That means centripetal acceleration, just multiply the mass times the centripetal force, just multiply the mass times the centripetal acceleration. So that becomes mass times centripetal acceleration, which is v squared over r. So we are saying m v squared over r is going to be equal to T1 sin theta plus T2 sin theta. So the mass in this case is 0.1. This ball we've been told is moving at that velocity of 8 radians per second. Now the velocity has been given in terms of angular velocity. Now the velocity we are using here is the linear velocity, so let's convert that value to linear, and so that is given by v is equal to r omega. Now what is the radius here? So the radius is 0.2, so that is going to be 0.2 multiplied by 8. So 0.2 multiplied by 8, what we are going to get here is 1.6 meters per second. So that will be 1.6 squared divided by the radius. The radius is 0.2, and that should be equal to T1 sin, the angle is 30, and also plus T2 sin, the angle is still 30. So I can just remain with this equation which is here. Alright, so there is a squared here. 1.6 squared is 2.56, and then multiplied by 0.1, then divided by 0.2. That is going to give us a value that is 1.28, and that is going to be equal to, since 30 is 0.5, to be 0.5 T1 plus 0.5 T2. I can divide everything by 0.5. (1.28) divided by 0.5, that is 2.56, and that is equal to T1 plus T2. Let me make T1 the subject of the formula. T1 is going to be equal to, I'll just take T2, this side becomes negative. So that becomes 2.56 minus T2. So this is T1, this is T1, so we can equate the other terms then. So that is going to be 2.56 minus T2 is equal to T2 plus 1.1316. So let's take T2 this side, let's take this value this side. So that will be 2.56 minus 1.1316, and that is going to be T2 plus T2. So 2.56 minus 1.1316, that is going to give us 1.4284, and that is going to be equal to 2T2. So divide both sides by 2. So T2 we are finding 0.7142. This is tension. Tension is given in newtons because it's a force. Let's go on and find T1. We can use any of the two equations which we have here to find T1. So let's use this one. So T1 is equal to T2, which is 0.7142 plus 1.1316. So that will be 0.7142 plus 1.1316. So that is going to give us 1.8458 newtons. These are the values for tension 1 and tension 2 then. Been given another question here. A wheel with a diameter of 80 centimeters. Okay. Speeds up from 30 radians per second to 80 radians per second. Now the linear acceleration of the edge of the wheel is 15 radians per second squared. The question is, how many revolutions will the wheel go through during this period? So we know the diameter of the wheel, we know the initial and the final speed. So let's get, well, we know the diameter, but we want the radius. We know that radius is actually diameter divided by 2. The diameter is 80 centimeters. Divide that by 2, that is going to give us 40 centimeters. But we don't want to work in centimeters, so multiply to convert to meters. We have got a centimeter on top, take a centimeter down, and then a meter on top. In 1 meter, we have got 100 centimeters. Centimeter and the centimeter cancels out. So that is going to be 0.4 meters. That is the radius. What else do we have? The initial angular speed, 30 radians per second. We have got the final angular speed, that is 80 radians per second. And then the linear acceleration of the edge. So we've been given linear acceleration as 15 radians per second squared. Okay. Now this is the linear acceleration, and linear acceleration can't be in radians. So the unit here was just wrongly written. It is meters per second squared. So meters per second squared. Now because this is in meters, this is in meters, I mean those two are in radians, but acceleration is in meters. Let's convert it also to angular terms. We know that linear acceleration is equal to radius times angular acceleration. Linear acceleration is 15. The radius is 0.4. And then what will be the angular acceleration? So just divide both sides by 0.4. So that will give us 15 divided by 0.4. That is going to be 37.5 radians now per second squared. Now that you found this value, well, when we want to determine the number of revolutions, we need to know the angular displacement. We know that 2as is equal to v squared minus u squared, but you are talking about angular terms. That will be 2 acceleration becomes angular acceleration, s becomes theta, that will be omega final squared minus omega initial squared. So this becomes 2 alpha is 37.5. We want to find theta. The final speed is 80 squared. The initial speed is 30 squared. So 2 multiplied by 37.5, that is going to give us 75, and then times theta. Then we've got 80 squared minus 30 squared. That is 5,500. So to remain with theta, divide by 75. 5,500 divided by 75. That is going to give us 73.33 radians. Having found the radians, now we are able to determine the number of revolutions. How can we do that? We know that 1 revolution is given by 2 pi radians. What of 73.33 radians? How many revolutions are here? So that will be 2 pi x is equal to 73.33. Divide both sides by 2 pi. So x remains 73.33 divided by 2 pi. That is going to give us 11.67 revolutions. The last practice question here. So we've been given a ball that has been fastened to one end of a 24 centimeter string. So this string is 24 centimeters. And then it makes an angle of 30 degrees with the vertical, and it moves in a circle. Now I want to find the velocity of the ball in this circular path. So this is a ball here. There's a tension. So in this rope there is a tension. There is a tension in that rope. Now, what are the forces acting on this ball? We have got the weight force, mg. Apart from mg, we have got the x component of this tension. Okay, the x component of the tension. And then we've got also the y component of the tension. Now, how do we find the x component of the tension? So I can simply remove the tension so that I'll work with its components. I'll remove it from there. Alright. So it was like this, and then it made an angle of theta here, as we can see from here. Now the tension is there. So now it goes like that. So this becomes the x component. That becomes the y component. Now since the angle is here, how do we find? So if we are talking about sine of the angle theta will be opposite. The opposite is x. Hypotenuse is the tension. So that means x is the tension sin theta. And then y is actually going to be tension cos theta. So x here we said t sin theta, and then this is going to be t cos theta. Now we work in components. Let's start with the x component. Okay, let's start with the y component in this case. In the y component, all the forces which acting in the y, we have got t cos theta. T cos theta should be equal to mg because they are going in opposite direction. So this will be t cos the angle theta is 30 degrees. Mass, okay, we don't know the mass of this ball, but we know gravity is 9.8. Cos theta is 0.866 times t, and that is going to be 9.8 times the mass. So divide by 0.866 to remain with the tension. So tension is going to be 9.8 divided by 0.866. So that is going to give us 11.316, but there is mass there. Now let's go in the x component. Because this thing is moving in the circle, the x component of the tension is the one which is going to be responsible for the centripetal force. So as it is moving, there is always a force that is pulling this ball towards the center, and that is the centripetal force. Centripetal force is going to be due to the x component or the tension force. So I was going to say centripetal force is actually equal to T sine theta. Centripetal force is given by mass times velocity squared divided by the radius. That is equal to tension. So where there is T, we are going to substitute this value found here. It is 11.316 m, and then sin the angle is 30. Okay, so we are saying that mass is going to cancel out on both sides, so we remain with v squared divided by what's the radius of this path. Now radius, as we can see, what we have is a triangle here like this, where we know the angle there, we know this is 24, we want to find radius. So says sin theta is equal to opposite is the radius, divided by 24 centimeters. So we can convert the 24 centimeters to meters. That is 0.24. That is because 24 divided by 100 gives 0.24. Just divide by 100 to go to meters. So that means R is actually 0.24 sin 30. And you know that sin 30 is a half. And half times 0.24, that becomes 0.12. So we're going to substitute 0.12 here, and that is going to be equal to sin 30 is a half multiplied by 11.316. We are going to find 5.658. So let's cross multiply these values. So we're going to have v squared being equal to 0.12 multiplied by 5.658. So v squared is going to be equal to 5.658 multiplied by 0.12. So that is going to give us 0.67896. To remain with v, we are supposed to square root this value. So square root that, we are going to get 0.823 meters per second. So this is the velocity of this ball. Well, if this video was helpful, you do well to subscribe to the YouTube channel to follow up with more videos. Stay blessed.